Hi, my name is Eleanor and this is Game On's Lesson 4 on Biodiversity Conservation. One of the first things we need to understand as to why biodiversity conservation is so important is that it's not about saving a species or a set of different species because of our emotional investment. It's also not because a specific mammal, insect or flower looks cute or funky or is generally to our liking. Biodiversity conservation is, above all, critical to help keep our ecosystems in balance and, considering the problem we're facing today, it's also critical to help tackle climate change. The European Commission itself summarises it as follows: we cannot address biodiversity loss without tackling climate change, but it is equally impossible to tackle climate change without addressing biodiversity loss. That said, let's address the basics. What do we mean by biodiversity? In a nutshell, biodiversity is everything that involves life on our planet. In that sense, biodiversity is understood and studied according to three different types: genetic diversity, which refers to the variety within a species; species diversity, which refers to the variety of distinct species; and ecosystem diversity, which refers to the variety of different ecosystems. Let's dive deeper into these three types. Number 1, genetic diversity. The first thing we need to understand about genetic diversity is that it makes it possible for a species to adapt to when the environment changes. So, having a large genetic diversity, in other words, a big gene pool, positively affects ecosystem resilience and functions. Biological variations at the DNA level forms the basis for all biodiversity. In the image that we're currently seeing, the colours represent alleles, variants of separate genes, allowing for genetic diversity. This means that individuals from the same species carry 2 copies of every gene, one coming from each parent. Considering this, genetic diversity refers to all the different genes contained in all living species, including individual plants, animals, fungi, and microorganisms. The second type, species diversity, refers to all the species present, as well as to the difference within and between these different species. Finally, the third type, ecosystem diversity. Whereas ecosystems are understood as areas where communities of living organisms interact with each other and their non-living environment, ecosystem diversity refers to all the different habitats, biological communities, and ecological processes, as well as to the variations within individual ecosystems. Now, bearing ecosystems in mind, their importance as hubs of different conflating living organisms is explained by what they bring: fundamental services for the balanced functionality of the planet. In other words, the interrelation of living organisms among themselves, and between them and the non-living environment, provides what we have come to call ecosystem services. Think about them for a second. A bee by itself, with no interrelation with another living organism, wouldn't get so far. The same could be said about us, humans, or about any other species. Interrelation is, needless to say, vital, crucial for life to happen. Of course, pollination is just one of the many services functional ecosystems can provide. Ecosystem services include the provision of services, such as food supply, clean air and water. They can be regulating services, for instance, modifying the climate and hydrology, allowing for nutrient cycling for the soils, or cultural services, which can include positive elements for human well-being, such as recreation or spiritual fulfillment, among others. And what are the interrelations between ecosystems and climate change? Let's bring 2 crucial ones to the table. Firstly, the conservation of ecosystems can greatly help with climate change mitigation. Take carbon sequestration, for instance, which is the process of capturing and storing atmospheric carbon dioxide in geologic formations and oceans. In order to have some degree of control over the global increase of temperature, carbon capture is key. Then, the conservation of ecosystems can also greatly help in adapting to climate change impacts. How? For example, with floods, an area with trees and plants can absorb and drain excess water, helping to prevent or diminish the impacts of floods. An ecosystem that has been destroyed, deforested for instance, and is now barren land, will not have the same capacity to absorb water. So, the conservation of biodiversity will be critical to mitigate and adapt to climate change. But we also need to be careful since we expect climate change impacts to deeply affect biodiversity. Remember the European Commission quote at the beginning of this lesson? We cannot address biodiversity loss without tackling climate change, but it's equally impossible to tackle climate change without addressing biodiversity loss. Needless to say, climate change will have deeply negative effects over ecosystem degradation, the loss of valuable ecosystem services and, without a doubt, biodiversity loss. To put it in crude terms, a scenario where we'll see a mass extinction of species. It wouldn't be the first time in the history of life on the planet. As a matter of fact, in the past 500 million years, Earth has already experienced 5 mass extinctions. The first one, the Ordovician mass extinction. What happened? Abundant plant life removed carbon dioxide from the air, causing global cooling and glacier formation. This led to a drop in sea levels. Most life at this time was in the oceans, and, with the reduction of these habitats, mass extinction occurred. The second one was the Devonian mass extinction. One theory suggests that land plants developed deep roots, releasing an abundance of nutrients into the oceans that fed algae. Because of this, algal blooms consumed vast amounts of oxygen into the oceans, suffocating many species. The Permian mass extinction was the deadliest extinction in history. 96% of all life perished. Scientists believe that volcanic activity in Siberia put massive amounts of carbon dioxide into the atmosphere. Bacteria that thrive on CO2 began producing methane. Large quantities of both gases warmed the planet and combined with Earth's water, making the ocean and rain acidic and creating a highly toxic environment for life. The Triassic mass extinction was the next one. Some scientists theorise that volcanic eruptions spewed tons of CO2 into the atmosphere, which trapped heat and acidified the oceans, causing this mass extinction. Other scientists contend that an asteroid or comet impact triggered the extinction. About 80% of life was lost in this extinction, including most mammals. Then came the Cretaceous or KT mass extinction. You got it right. This is the one that wiped out the dinosaurs, along with about 75% of all life on Earth. A widely accepted theory is that an asteroid landed in Mexico. The impact would have ejected enormous amounts of debris into the atmosphere, causing global temperatures to drop. The impact may have also caused local fires, earthquakes, tsunamis, and acid rain. With dinosaurs out of the way, mammals flourished, eventually giving rise to Homo sapiens. But let's be aware of one very interesting fact. 3 out of these 5 mass extinction events were strongly related to climate change: the Ordovician, Permian, and the Triassic-Jurassic. Where do we stand now? Well, the news isn't great. We're currently undergoing the 6th mass extinction. It's formally being called the Holocene extinction, but it's also known as the Anthropocene extinction. Anthropocene, as in us, humans, being the driving force behind it through our ways of living. Just put together activities such as overhunting, deforestation, the pollution of air, water and soil, simply to name a few, and you can already start to understand why, today, already a total of 1 million species of plants and animals are at risk of becoming extinct within the next few decades, and those are only the ones we're aware of. And while throughout history many species have gone extinct without the need for a mass extinction scenario, this case is different. The current extinction rate is at least 1,000 times greater than the normal extinction rate. What do we mean by a normal extinction rate? A normal or background extinction rate is the average rate of extinction based on the longevity of species through time without human influence, as determined by fossil records. So what should we be focusing on? All species and ecosystems, truth be told, but we should be extremely careful with species that are already endangered and at risk of extinction. We're all aware of some globally renowned ones, such as the panda or the orangutan, but let's also not forget that not all species are that noticeable or fit human standards on animal beauty. Remember for a second the bees, as well as other pollinators. You already know how critical they are for the full functionality of life on the planet. Nevertheless, pollinator insects are currently not even protected, even though their loss is a significant one and ongoing, and can already be felt in some places of the world in sectors like agriculture and the economy. Let's have a look at some endangered species that are not that well known, but should be. The European mink, for instance. Formerly present throughout most of Europe, its range has been reduced by over 85% since the mid-19th century. The remaining population is small, fragmented, and declining. The most viable population in Europe is in the Danube Delta. The European mink is currently extant in Estonia, Ukraine, and Romania. Overall, it's of critically endangered status. The common hamster is another critically endangered species. It's undergone severe range and population decline in Western, Central, and Eastern Europe, and now has a highly fragmented distribution in these areas. It's extant in Poland, Germany, Austria, Slovakia, Ukraine, Hungary, Serbia, Romania, Moldova, and Bulgaria. The Bavarian pine vole, endemic to the northeastern Alps, is also critically endangered. The species is now known to be present only in Rothan Mountain, located in the northern Tyrol, Austria, where it occurs in altitudes between 730 and 1,100 metres above sea level. The Seika falcon is an endangered species. From 1993 to 2012, a 19-year period, there was a very negative population trend, with a total decline of 47% of its population. According to BirdLife International, the small European population is estimated at 350 to 500 pairs, equivalent to 710 to 990 mature individuals. It's extant in 10 countries in Central and Eastern Europe. The Egyptian vulture is another example. Within Central and Eastern Europe, it can be found mainly in Bulgaria. In Europe, the breeding population is estimated to number 3,000 to 4,700 breeding pairs, almost half of its global range. Overall, European populations of the Egyptian vulture have declined by 50 to 79% over the last 3 generations. The common skate, as the name already implies, was historically one of the most abundant skates and rays in the Northeast Atlantic. Nevertheless, it is now considered to have been extracted from most seas. An emblematic species, the stellate sturgeon, can be found in the wetlands of Ukraine, Moldova, Serbia, Romania, and Bulgaria. Currently, global catches show a decline of over 98% in the last 15 years between 1992 and 2007, which is believed to reflect a decline in the species population. In the Black Sea, in Romania, from 2002 to 2005, catches of wild individuals dropped by 72.5%. As a result, in 2006, commercial catching was stopped. The Croatian dace is only found at a very small karstic stream, the Stanica jaruga in Croatia. The main threats that this critically endangered species faces are water extraction and the introduction of other species, namely trout. The Babienko's plump bush cricket is only known to live in the Slovak Karst National Park in Slovakia. The population of this species is severely fragmented, with 6 small and isolated subpopulations with little genetic exchange. Thus, they may become extinct without a possibility of recolonisation. The population size is small, with no more than 30 mature individuals per hectare, and the current population trend appears to be declining. The Austrian Gymnodinia is an orchid endemic to 3 specific places in Austria. The species can be found from 1,800 to 2,000 metres of altitude. This orchid is currently threatened by plant collection and recreational activities. Like all grassland orchids, this species requires a specific level of grazing. Too little and the species suffers from competition with other plants. Too much and the diversity of the species is lost. The Hungarian fawn is endemic to Central Eastern Europe, specifically in the Carpathian Basin, and to the Northern Balkans. Confirmed records of the species are from Hungary, Slovakia, Croatia, Romania, and Serbia. However, it appears that the species range has greatly diminished in recent years, with current confirmed records known only from the Danube floodplain in Hungary and Croatia. With these endangered species in mind, back to the big topic, extinction, and the problem it poses. As indicated before, interrelations between living and non-living organisms are crucial for all life on Earth due to the ecosystem services they render. If one species ceases to exist, it affects another one, which affects another one, and so on in a domino effect. And with that, the less diverse the ecosystem, the less resilient it is. What is resilience? The ability of an ecosystem to resist damage and recover quickly, such as in cases of fires, floods, pests, diseases, and so on. The ideal scenario, therefore, is the inverse one. The more diverse the ecosystem, the higher its resilience. Therefore, saving one species can mean saving other species that live there, as well as their habitat. So, what exactly is being done in terms of biodiversity conservation? In Europe, we have in place nature and biodiversity related laws, such as the Birds and the Habitats directives. Moreover, there are global treaties regulating wildlife trades, such as the Convention on International Trade in Endangered Species of Wild Fauna and Flora. Furthermore, there are several strategies and methods being addressed, such as green-blue infrastructure. Here, we're referring to nature-based solutions. Green-blue infrastructure is aimed to act as a network of green and blue spaces that provides multiple significant benefits for both people and nature. For example, green roofs, tree lines, woodlands, polders, oxbows, and so on. Green-blue infrastructure puts these elements together into a network in order to enhance their connectivity and strengthen the multiple benefits for nature and society. And you can be a direct contributor to this scheme. Think of your own green roof, for instance, or a green wall. They can become homes for biodiversity to thrive. Indeed, there is much more that still needs to be addressed, such as supporting education and local initiatives, or giving support to small farmers to confront problems brought by monoculture in order to create sustainable, nature-friendly agriculture. But, as a practical example of initiatives presenting a positive approach and positive results, in Europe we have Natura 2000, the largest coordinated network of protected areas in the world. In 1979, the adoption of the Birds Directive aimed to protect all wild birds and their most important habitats across the EU. The Habitats Directive, adopted 13 years later in 1992, introduced very similar measures but extended the coverage to around 1,000 other rare, threatened or endemic species of wild animals and plants, often collectively referred to as species of European importance. The Natura 2000 network is a result of both directives to give practical protection to biodiversity in the continent, aiming to ensure the long-term survival of Europe's most valuable and threatened species and habitats, whilst providing benefits such as clean air and fresh water, ecosystem services, and many more. On the global level, unfortunately, biodiversity conservation is still lacking. We encourage you to have a look at the most recent report from the Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services. Its global assessment report shows that our current biodiversity conservation trajectory is not enough to meet our conservation targets. Yes, any goal we currently have for 2030 and beyond must be accompanied by drastic transformative changes in the system, be it economic, social, political, and technological. In other words, to tackle climate change, we must drastically change.